Right. Now, today, what is the agenda? That this program should have a function. This program should have a function, but this function should not be a normal function. It should be a inline function. It should be an inline function, right? Now, first, I will be making a inline function in context of a normal procedural program, right? And then I will create a inline function with respect to a class. Getting my point? I'm always telling you that we can write a program with respect to a procedural oriented way in C++. We can also write a program through classes. That becomes a object oriented approach, right? So if I just ask you that, okay, you just create a inline function without using classes, so that is my first agenda, right? So that means I will be creating a program which will not make use of classes and object, right? I will write a simple procedural oriented program in C++, and then we will do it with the class also. Got my point here?
Yes, ma'am.
Okay. Now I hope you are not seeing me, you are not seeing my screen. All of you should have, I trust you that you are doing what I'm saying, right? So open your dev C++. Now declare your header files. That is the first thing without looking at me. Declare your header files. Right? This is my first instruction. Declare the namespace. Next, declare your namespace. So whenever you will be asked to make a program, make sure that you include these two things before, right? So we have already explained, we have already done what is the functionality of these two header files. Now, on the first day, I had told you how to make a function in C++, right? And I've always been telling you that a function, whenever function comes into your mind, three things becomes very important. One is function declaration, one is function definition, and one is function call. Yes or no? Whenever function comes into your mind, you think about these things?
Yes, ma'am.
Yes, you think, right? Now I will just show you the PPT. A normal function. This is a normal function which we did in the first class. And just observe. Just observe. This is the function definition. What is function definition? It just tells you what your function is doing. Yes or no? If I say add is my function, but I have to tell the computer that this is how two numbers will be added. So function definition tells you that, okay, these will be the parameters passed to it, and this is what my function will do, right? And the other is function call. You are just calling your function with the required parameters that match here, right? So now here you see that uh, I didn't declare my function, right? I didn't declare my function here. So in C++, we can avoid not to declare our function. Straight away, this piece of code is function declaration plus definition. And this we have done, right, in the classes also. This is function declaration also and function definition also, both, right? So these two, this one thing is using function declaration and function definition both, right? So you need not to declare your function. You can omit that, right? Now I will go here. Now I will give you another instruction. Create a function. Create a function which, suppose I want to calculate the cube of a number, right? I want to calculate the cube of the number. Go to your screen, your own screen. So create a function called cube. All of you create a function called cube. Just give the name, any name of your choice, but obviously it should match with what your program is all about. That is the best way of doing programming, right? So you write the name of the function, and I am telling you that this function will be, obviously a function should return, right? So this will be, suppose, returning int. So you all know how to write a function, right? So it should have a return type. So put the return type as int, suppose. In my case, I've put int. Now, the next thing is a function can receive parameters also. And when the objective of my program is to calculate the cube of a number. So obviously it will require some parameter, yes or no? So my next objective is that pass the, I want to determine that this cube may take some parameter, the function name, and suppose it takes a int parameter. Suppose something I kept s. Right? Now, I told you, I will be doing functional declaration and definition at the same time. Right? Now, make the body of the function. Make the body of the function. So I have a function called cube. The return is int, and this function will be accepting a parameter of integer type. Right? Now this should calculate the cube. Right? So I should have some mathematical formula that will help you to create this, which will help us to create this, create the cube of a number, right? So cube is nothing but 2 into 2 into 2, right? So in the function, you do it. So I have s, right, into s into s. Suppose I'm calculating the cube, right? And this should be, whatever operation you have done, this should be returned to the calling function, right? So after performing this, it should return. So append a return statement to it. And every statement in C++ is terminated with a semicolon. So by now, if you paid heed to my instructions, you should be able to declare the header files. You should be able to create a function that returns int, that has a function name, and that will accept some parameter. And when it will calculate the cube of the number, it will return. Now this return means that you will be returning it to the calling function, so that there it can print. So this is one function definition and declaration that we have done. Now, suppose we make another function. A program can have n number of functions, right? Now, create another function int, create another function, suppose increment, inc I have named, you can have any other function name, right? The return type of this is suppose int. And what it will be doing, it will accepting some integer. So obviously, if it accepts integer, I have to say that the parameter is some variable of type int. Now this will also be returning something, right? Suppose any operation like increment, it will be incrementing the value of a. So some logic I have to apply, right? So this will be, suppose it will be returning the pre-increment. Pre-increment, what is this? Pre-increment, and then I have kept my variable name. So when some value from the calling function, when some value will be supplied to a, it will do increment. And in this case, what is the increment we have used? Pre-increment. That means first increase the value of a and return it. So if I pass from the calling function, I pass 5. So plus plus means first increment. So 5 changes to 6. And if it would have been a plus plus, then first use the value of a, then increment, right? Now these two functions I have created, I have declared and defined in a nutshell, right? Now what is left? Always the calling of functions happens from main. Dear, have you opened your editor or not?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay.
Yes, ma'am.
Now, okay. Now, all the calling I will be doing from main function. Right? Now see, I have to pass some values to S to A. Right? Suppose now you declare some variable, suppose int, declare some variable. You all know how to declare a variable, right? Suppose I declared A is equal to 10. Right? Now I want to call the functions. I have to start calling the functions. So in cout statement only I will call the, you can call individually and then do the cout statement, but I am doing in cout. The cube, right? The cube of the number is, the cube of the number is, so anything that is printed within the codes will be displayed on the screen as such, right? Here. Now I want to call the function. What is the first function name? Cube. I want to call this function, right? If I want to call the function, I will just write the function name cube, right? And suppose I passed, now see dear, this is the function, this is the function, I'm calling it. So some integer I have to pass, right? Suppose I have passed 3. Right? Now, the same statement I'm copying. What is the second function I wish to call? This one, increment one. So I want to, the increment of the number is, what is the name of the function? What is the name of the function? INC. Right? And here, because one variable I just declared, directly also you can keep here, but because I declared one variable, I will pass A. right? Now, how you wrote a program, now you will compile it. And I told you execution of the program starts from main. The control will start from here, int main. There will be a variable of type int that will reserve some memory, right? It will come down. It will say the cube of the number is on the screen. It will call a function cube, right? It is for calling, this is function call with the desired parameter 3. The control will go here. The control will go here and it will do 3 into 3 into 3 and it will return me the result. Return to whom it is returning? To the calling function, right? It is returning to the calling function. And then this thing will be printed. The cube of the number is whatever the result is, 27. Similarly, for this statement, this is the function call. Wherever you see the function name and the parameters, you say that it is a function call. This will go to A. It will increment the value of A. It is 10. It will give you 11. And the result will be printed. Right? Now, this is a normal function, which you know. But what is our agenda, as we were talking about, that I want to make these two functions inline. Yes or no? That was my agenda. Dear, this much
Yes,
code,
ma'am.
all of you have written or not? Yes, okay.
Written.
Okay. Now, this is a normal function that will take this. Where is it? This is a normal function, right? This will take this approach. You have the main function. You are making the calling. The control transfers to the definition of your the body of your function, and control returns, and the program will end. Right? Now I want to have an approach like this inline function, where as soon as I call a function, the function body is pasted. This is my thing. This is what I want to do. First, let me see if it has some errors. So the cube of the number is 27 and the increment of the number is 11, because 10 gets incremented to 11, right? Now, my duty is to make the functions inline now. So yesterday we did, in order to make a function inline, the only thing is that we have to add a keyword of inline. So what I will do, this is a normal function. To make it inline, I will just write inline, inline. Here also, I will make the function inline. So we have two functions and I am making them inline. Now, as a user, I will not come to know the difference. I have no way to know the difference, whether the compiler has really accepted my request, because I am not giving a command. I am not giving command means if I have said something to you, you have to follow. It's like do or die, you have to do it. But I told you that the authority of making a function inline is solely based upon the compiler. You can, if I request you, suppose I say I'm requesting you to open the dev C++. Now some may follow, some may not follow. But if I give you a command that it should be opened, then it should be opened. But this making a function inline is just a request. and not a command from the user. So as such, on the output will remain same. But what will happen now? If I make this two functions inline, the flow of control will be different now. So how it will be different? The execution starts from int main. I will come to the first statement, right? Then here the function is being called. As soon as the function is being called, what the compiler will do, it will take the function body and paste it on this part of the program. So the function, the control will not get transferred here, which is the normal way of working of a function. But what that function has to do, that body will come and sit here. So that the unwanted movement of the control going from the function call to the function body, then returning the control and displaying the result. And I told you that if certain statements were here also, some statements were here also, right? So the compiler also should know that, okay, after the control has come here, the next instruction that I have to execute is this and this. So the CPU has to even store the result, store the memory, the address of these this instruction, right? So various overheads are encountered while calling the function again and again. And if the function body is very small, as in this case, and if this function is being called over and over again, then overhead will be more, productivity will be less. Now you are sitting in your class, suppose now you are sitting at your home, but when you used to sit in the classroom, you know that you feel thirsty again and again, right? So one approach which usually you adopt is that after every class, you wish to go outside and drink water. So the control is being transferred from where you are to the place where the tap of water is there. So you come and go and come and go. But on the contrary, you look at a situation where you have bought your water bottle and you have kept just besides you. Those people who go out and come back, they take 5 minutes, and you sitting in your place don't even feel that some time is getting consumed because the bottle is just next to you. Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. So execution will not have, results will be same. Compiler must have done inlining or must not have done inlining. The inlining may not have been in the cases, as I told you yesterday, it may not have been in the cases where your function body has lots of looping, do while, go to statements, recursion is involved. So in that case, when your body of the function is very complex, in that case, compiler thinks that we may not make this function inline. And in the when I was dealing with classes concept, I told you if your function is very small, better to put it in class, better to define your function in the class. Because in the class, every function that you define in the class becomes inline by default. So let's do, this was a program, normal program, procedure-oriented program done in a C++ way. Now we will hop to object-oriented approach, right? By making a class. Got my point, dear?
Yes, ma'am.
Okay. Okay. Now again, please all of you. It is a command now. All of you should open your editor, right? Now, same. I will give you some instructions, right? And you will be doing it. But now, by making use of a class, right? So again, open your. See, dear, the scope of programming is huge, right? There are n number of ways you can try, and as being a computer science student, right, you people can explore it to any extent, right? So that learning happens. So on your behalf, you can explore anything, right? So which even I may not be knowing, right? Now what you do. Now we will
Ma'am,
implement this.
like sorry for the interruption. For
Yes.
like I have a doubt.
Hmm.
Like if we use the command like the word called inline, our
Hmm.
program is taking like a bit more complex compilation time rather
Hmm.
than we use int normally.
You saw the time.
Yes, ma'am. Like it was 2.6 if I used inline,
Hmm.
and it was
That is
1.6 if
what.
I used int.
Yes, dear. The thing is that again I told you that it is just a request. You don't have any hold of this. You try various other, like try to make your function body complex. In one you make simple. Trying different versions and keep on compiling and executing them. Then see the patterns. But again, I have told you that maybe because it is just a request, I don't have the control on it as a programmer.
Yes, ma'am. Got it.
Right? So I cannot do if the compiler say no, I don't want to implement this as an inline function, then okay, it may not do it. But yes, from your side, you can try make some like complex functions and see how the time is changing. Now see, you were smart that you saw the compilation time. I didn't see it, right? So that is what. Uh, just try it, but this is a request only. I can't force my compiler to follow inlining.
Yes,
Okay?
ma'am. It's just a request.
Huh. Then uh, now I will give you instructions and you follow it, right? Now, one case I will not deal with, I will deal with the other case. So one case is that if I define the function inside the class, then it will be automatically a an inline function. So I will not do that. What I will do is that if a function is only declared inside the class, if it is declared inside the class, only declared inside the class, I want to define it outside and want to make it inline. Got my point? I have just declared a function inside. What I want to do is I want to define it outside and I want to make the function inline. Yes, this the objective is clear.
Yes,
Yes,
ma'am.
ma'am. It's clear.
Yes, ma'am.
Okay, dear. Defining the function outside class and making it inline. Now, all of you go to dev C++. Now this you can copy the header files. Keep the header files. Now, whatever I say, you do it, right? You follow the instructions only, right? Make a class. Make a class. So in order to declare a class, first, Declaring means just the class and the class name, right? Class, suppose my class. The name of the class is my class, suppose. Right? Obviously, again, to reiterate, a class is just a listing, or it's just a template consisting of functions and attributes. So now we'll start creating a body of class. Declare two variables. Declare two variables, A and B, suppose in public. Suppose in public, or keep it private, dear. Keep it private. It's better to keep the variables private, right? In private. So I have declared two variables, int A, comma B. If I don't tell that this A and B are private, but still by default, even if I don't write private, they will be private only, because default everything inside the class will be private. Right? Now, declare a function. Suppose I will be just declaring it here, because I will be defining the function outside the class, right? So just I